Hi everyone, welcome back to our series of videos for ENGR 359. This is the second video of our series, and in today's lab, we'll be interfacing with physical hardware, using program states and interrupts, and debugging through the serial monitor. My name is Logan, and let's get started with the course information once again. If you are looking for contact information for myself or Dr. ENGR, please see the course syllabus found on Canvas. As before, I'll be running open office hours if you have any questions regarding the lab, and you can find the time on Canvas as well. For this lab, you will once again need your TiVo Launchpad and an installation of the Inertia IDE. Oftentimes, an embedded system must accept some form of signal from the outside world, whether that be from a user or a sensor. This can be done in a number of ways, but generally the most effective method is through the use of interrupts. An interrupt is a condition outside the normal program that the microcontroller must handle through the use of an interrupt service routine, or ISR. These interrupt signals can be generated by software, such as through a timer, or by an internal or external hardware. For example, a keyboard or a clock. When an interrupt is generated, the processor must save the current state by pushing all vital information to the stack, and perform an action called context switching, where the processor changes what instructions will be run next. Once the ISR is completed, the processor then retrieves the information stored in the stack and continues on. Interrupts can be useful in this way, as you can change a program variable to accomplish something different in the normal runtime. In Inertia, we must follow a series of steps to attach an interrupt to a pin. To start, figure out which pin you need the interrupt on. After doing so, we can define our pin number in the program. Choose an easily identifiable handle for this purpose. Next, we need to create the ISR that will be used to handle the interrupt request. This is essentially just another function within the program. It must be a void function, as we will not be returning any values. Set the pin to an interrupt with an internal pull-up resistor, and finally, attach the interrupt to the correct pin. I'll go through these steps myself to show you how it's done. The first thing we're going to do is define our pin number. I'm going to create a new constant integer and give it a suitable handle and set my pin number to whatever I need to. So in this case, constant integer, we'll say button 1 is equal to pin 2. Next, I'm going to create a new function called void button 1 triggered. And in this function, we're going to do something when button 1 is pressed. Next, we need to set our pin mode. So pin mode, and we're going to specify button 1 and set this to input with a pull-up resistor. Next, we can attach our interrupt. Go digital pin to interrupt with button 1. Set the ISR that we need to button 1 triggered, and finally we're going to set the condition to falling. So now when you push the button, the signal on this pin will go from high to low, or false, and once that happens, we will generate an interrupt and do something in the ISR. This could be changing a program variable or what have you. If it works correctly and your program is free of errors, you should now be able to compile your code and then upload it to the TiVo board. As a reminder, for a complete procedure, please follow the lab manual. One thing that is important to remember when using hardware is there is no signal that is ideal in the real world. When you push a button, it does not create a perfect square wave, but instead will be noisy. This can cause the button state to change more than once per button press, seen in the graphic here. One way to fix this is to add a resistor and capacitor to create an RC circuit which lengthens the time it takes for the signal to change. Otherwise, this problem can be solved in software by making sure the state cannot change more than once within a certain amount of time. We will be using this second option today in our lab. One other important tool that Inertia provides is the use of the serial monitor. We can use this monitor to print out information to debug our code if it does not work as we expect. To use this serial monitor, we simply start the service by using the instruction serial.begin with a baud rate of 9600. After this, we can use serial.print or serial.println statements to write to the monitor. If you find your code does not work correctly, you can use the serial monitor to print out different variables to see if they are changing properly. Otherwise, you can add different statements inside of conditional structures to see if those are activated as well. It is a straightforward but very useful tool for debugging issues. For instructions on how to use the serial monitor, please see your lab manual, as it gives you a pretty good outline of what you need to do. As for the lab submission, please fill out the lab report, record your final working product, and submit those two items with your main.ino file to Canvas for marking. If your Part 3 is working properly, it should look like mine here. You'll see that the LED blinks normally, but by clicking the second button, I can change what color is flashing. If you encounter issues with this part, make sure to note the hints that are given to you in the manual. If your program is still not working, try the serial monitor to debug your code. If all else fails, reach out to me through the usual methods and I'll try to assist you. Thank you for taking the time to watch this video, and I'll see you in the next one.